All right, so today's date is Wednesday, January 15th, 2020. Make sure your name and date are on your paper. We're in Algebra 2. We are on lesson 8-2, relating exponentials and logarithms. Again, we're trying to make sure that we understand that logarithms are the inverse of exponents. I know I read it. I need to fix these standards to make them objectives instead of standards. I'm kind of basing this off of last year. Let's start with some vocab. If I'm trying to take the inverse of a function, then what is another word for saying inverse? And there's a few different words you could use. All of them are pretty valid. You want to go for it? Yeah.
Opposite?
Opposite, yeah.
That doesn't really fit.
It doesn't really fit, but I like that word, so I'm going to write down opposite. Opposite in math more means if I had a positive, make it negative. There is a word that fits a little bit better in there. The opposite of to do. Is there a quiet raised hand? Leo basically had it if he wants to put his hand up. Yeah, Leo? To not do? You're really, really close. Can you make that into one word, Leo? One word that has the word do in it? Starts with a U? A word that has the word do in it, that the first letter is D. You can give it off to someone.
I'll give it to Aurelio. Undo.
Undo. Thank you, Aurelio. I'll take your card. Leo, I'll take your card. Aurelio. A function that undoes, I guess, is the full word that makes it make sense. But you're undoing a function. So if I square a number to undo that function, I am going to square root. That will be the opposite. Or the undoing of the function. That is an inverse function. So that is our whole unit. Our unit is logarithm, so we're undoing an exponent. Whenever we have tools in mathematics, the whole idea is I will give you a tool that does something, and I'll give you a tool that undoes something. Think of the exponents as the hammer. I can hammer in a nail. Think of the logarithm as the back of the hammer that can take out the nail. I can do and undo something. So let's do a notice and wonder. I just gave you a really cool graph. There's a ton of information on this graph. I want to know what you notice, something that you observe about this graph, and I want you to write it down. Everyone's probably going to have something a little bit different. What you notice about the graph that I put up here. And I want things that are mathematical. So you can say, I don't want things like this. I don't want you to say, I noticed one is a blue dashed line and one is a red solid line. I mean, yes, you're right, but what's mathematical? Maybe you observe some interesting pattern with the numbers. Maybe you notice something interesting happening with this dotted line and the relationship between that dotted line and the blue and red line. Maybe you notice something about what's happening with the certain quadrants. What's something mathematical, some pattern that you see in here? So I'll give you guys another 10 seconds. Find some pattern, write down that pattern. Now, if you're not sitting next to someone, you're going to have to stand up. But this is a think, pair, share. You've done the thinking. Now you are going to do the pairing. Pair up with someone. What did they notice? Is it something different? Is it something the same? Is it basically the same thing in a different way? Pair up with at least one other person. You can do a group of 3 if you'd like. Chewy, that has a group of 3. Go turn that into 2 groups of 2.
So which one's the mathematical one?
If I share my answer, do I get my participation card in?
Yeah. And you can share someone else's answer to get your participation card as well.
My hand's up first, so that means.
That's me on my phone.
Oh.
Interesting. Okay, so go ahead and finish up those conversations in 5 seconds, and you can stay where you are because I'm going to do another think, pair, share. So if you want to stay where you are, that's fine. If you want to move back to your seat, that is also okay. So with a quiet raised hand, someone share. I see Jaden. Yes.
The coordinates are like opposites. The red and blue are opposites. Like it's like 0, 1, 1, 0.
Oh, they switched the x and the y coordinates. Okay, that's interesting. I'm gonna write down a few of these, but let me hear them first. What's another thing that people heard? I'll go ahead and take your card.
He's like, well, that was good, but it wasn't what I
That
was
is
looking
amazing.
for.
That's the main thing that people see. Yeah, Beverly.
They're going like opposite directions.
Opposite directions. One's going to the kind of topish, or going to the top, one's going to the right. They're going in these different directions. Interesting. Okay, yeah, what else do we see? India.
The black dotted line has a slope of 1.
Oh, that is also very key to this. This black dotted line has a slope of 1. Nice. I saw one in the back. Do you still have your hand up, Emily? Yeah, Emily. They never intersect. That is also kind of interesting. I didn't mean to say it that way. That is interesting, and it will be changed depending on the types of function. But yes, I like it. Write it down. Yes, Ellery.
The lines are a reflection and the black dotted line is a line of reflection.
It's a reflection. Whoa! And I saw you doing this, but I want everyone else to do it too. Go ahead and fold your notes over this dashed line. Everyone do it now. Hold it up to the light, the projector, whatever it takes. Fold over that dashed line. If it is a true line of reflection, if we fold over that line, the blue dotted line should exactly map onto the red solid line. Is that true? Is Ellery correct? Do you guys verify that? I hear Leo saying no. Let me come see what's going on, Leo. Hold over the dashed line. A little bit hard to see. Ellery, do you mind turning on the lights really quickly so that people can see through the paper a little bit easier?
I mean, a little bit. Wow.
Do you see it? It should be true because that is exactly what the graphical definition of an inverse function is.
Yeah? No?
Okay. So, let's write down a few of the things that I can remember, and maybe I should have written these down beforehand. X and Y are switched. The dashed line slope is 1. Another thing is dashed line is a reflection. Well, that's not a good way of saying it, but dashed line reflection I think is a good way to summarize that. Dashed line reflection. I'm also going to write down they don't touch. They don't intersect. And there are some other ones that I really want to add on here. I just didn't have enough space. I really liked the observation that they went off to different directions. Everything that you guys said was really awesome. I mean, last year when I did this to my Algebra 2 class, they were giving me things like, it's a blue line, it's a red line. I'm just like, this lesson is not going to. You guys answered this perfect. So good job, everyone. Thank you. Okay, the next question is, what questions do you have now? And I want a specific mathematical question. If you ask the question, why, and it's not as specific as I would like. Something that would be more specific, an example would be, why, or what would happen if this line didn't have a slope of 1? Would it still be a reflection? Or something else. I don't want to give all the questions away, but I want you to think of your own mathematical question related to the graph that I put up here. Ask something specific. Again, you're doing this by yourselves, and then you're going to pair up with a different partner, or a different group, and share your questions. So you guys have another 30 seconds. Think up of a question. Go ahead and write it down. What question do you have? Try to finish writing in 10 seconds, or at least have it in your mind so you can share with your group. Looks like some people are writing, so I'm going to give you a little bit more time to finish writing your thoughts. All right, so I want you to, everyone physically has to stand up. We're going to fill the room really quickly. You guys know to walk the room. We have a lot of room to like walk around now. So everyone, walk around, wake up for 30 seconds. Walk around. Grab all of your stuff because you're going to sit down with them and then share your answers. You're not going to permanently sit there. I just need your pencil and your notes. Fill the room. Walk around, wake up, shake your arms out. You could do maybe high kicks if you're not going to hurt anyone. Fill the room. Are you guys getting more awake? Do you need to do jumping jacks?
Nope.
Now, with someone that you normally do not talk to, try to pair up. There are an even number of people, so there should be pairs. Talk to someone that you normally don't talk to. You guys are like study buddies.
Who?
Aurelio and Beverly?
I'm not.
No.
There's a proof.
All right, I want you to share your findings or what your questions were.
Oh, we're supposed to be
Share your questions. You can sit down if you want. You're paired up now. What questions did you guys have?
What if like one of them like didn't see you know how they like switch numbers like this is 2 4 this is 4 2?
So they're opposite.
Yeah. But like what if one didn't? This is like 4 3. But this one stayed the same.
It wouldn't be the same.
Obviously it wouldn't be the same, but like
What are you trying to say?
what would like would that like change the hours would change?
Yeah, it would change it.
Okay, but like would it not work? Like what if
No, it
this is
wouldn't
like
work. It wouldn't be the same.
Okay.
All right, so finish up your conversations.
Fine.
All right, quiet raised hand. If you can find your participation card to hand into me, that would be perfect also. Quiet raised hand, what questions did you come up with? You can share your question, your partner's question. What question did you have about the graph? I heard some really good ones. I'll make people share if no one volunteers. Yes, Jaden. You had a good question. Ask it
I
again.
feel like it was dumb.
It was a great question.
So what happens if the x and y's are not opposites?
Yeah.
That's exactly what I asked. Okay.
What? Like, what if they weren't? Is that possible? Could that even happen?
Yeah,
I love
that
it.
can happen.
What's another question? Anna.
So why does it jump? So
There's too much talking. Hold on. Guys, we're listening to Anna right now.
the distance between the dots doubles each time. So like exponential graph.
Whoa. You guys see that?
No.
The distance between here and here was a half. Then it's 1. Like, is that the distance that you're talking about? Or are you doing different
So
distance?
between the first dot and the second dot, it's. I guess the first time I noticed it is the x value is 1, then it's 2, then it's 4, then it's 8, or I guess the y.
Oh yeah, so 1, 2, 4, 8. It keeps doubling. And then what was the question that went with that?
Why does it do that?
Why does it do that? Interesting. Does anyone have an answer to that one? That one does have an answer that you've learned already. I'll give it away. This is 2 to the power of x, which is a doubling function. 2 to the power of 0. 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 will be 16. It doubles each time. If I change this to y equals 3 to the power of x, it would triple each time. Yeah, good question. I like it. Other questions? All right, go ahead and take a seat. So the question I will write down is, can the x and y not switch? For my notes. All right, so here is the big reveal. There should be no more talking now that I'm back into teaching mode. So graph. An inverse function will always reflect over the line y is equal to x. So earlier we were asking ourselves, well, why is it a slope of 1? What would happen maybe if I change that? It always has to be y equals x. And this is true for any inverse function. You guys want to play around with this for just a bit, where you get to sit back and watch Mr. Dell play with numbers for a sec?
Yep.
It means a little bit less work. So if I go over here to Desmos, I should be reflecting over the line y equals x. So let me graph y equals x to begin with. So in Desmos, this is how you play with math. If I go to projector mode. So y equals x. There's the line. Let me make this so that the line is a dashed line so it kind of matches up with what we had. So I have a dashed line right here. Can someone give me a function and an inverse function? I already named one of them. What's a function that undoes another function? I'll give you an example. If I do 2x, to undo 2x, I have to take half of x. Half of x. Those are a reflection of each other. To undo multiply by 2, I need to divide by 2. To undo a square... Oh yeah, go for it, Ellery. You had a question? Oh no.
No.
What happens if I have x squared? And this one is a little bit hard to see. Let me hide the other ones. If I have x squared, and zoom in here so you can see it a little bit better. If I have x squared and I undo a square, that's a square root. So square root of x. And that is shooting out the other direction. And you might be saying, well, Mr. Sindel, it's missing this lower half. And that's because you need the negative square root of x because of the domain problem. This is reflecting this parabola, reflecting over this line and turning this way. So it's reflecting over this line. Every single inverse function, with some restrictions in the domain, will always flip over this line y equals x. It's this cool graphical representation of what an inverse function is. All right, so with a table, it's even easier. Here we go. So I gave you the equation y equals 2x, 2 to the power of x. And you see that right here. Y was equal 2 to the power of x. So in this table, if I plug in 0 for x, 2 to the power of 0, quiet raised hand. Anything to the power of 0. Ellery. 1. Anything to the power of 0 is 1. I'm plugging in this 1 now into x. 2 to the power of 1. Quiet raised hand. Lots of people can get in here. 2 to the power of 1. Anna. 2 to the power of 1 is 2. 2 to the power of 2. Aurelio.
4.
4. Thank you. 2 to the power of 3. Sam. 8. So we see the pattern there. Well, let's come back up to our graph. You're going to use your graph. Let's fill in this one. We don't know what this function is yet. But I'm now going to switch the x and the y's. If this was a 1 in the y, it's now going to be a 1 for the x. And check what happens. When I have a 1 for the x, I have a 0 for the y. I'm just copying down those values. In terms of writing down an inverse function, it's as simple as switching these two. So what's the next one going to be? Quiet raise hand. Caroline. 2 and 1. 2 is x, y is 1. 2 and 1. Inverse functions are super easy here. What's the next one going to be? Quiet raised hand. That's Ziri.
4 and 2.
4 and 2. Perfect. Next point is going to be what? Cheyenne. 8 and 3. All the inverse function does is it switches your x and your y's, which is the same thing as saying you're reflecting over the line y equals x. And if you want to get really deep with your understanding, why is it flipping over y equals x? Because it's saying I can interchange y and x. If I have y is equal to x, that means x is equal to y, which means in terms of your coordinates, your x and the y can be switched because x is y, y is x. That means in my coordinates on my graph over here, I had x coordinate of 0 and y coordinate of 1. I can switch those because y is x, 1 is 0. Or sorry, 1 is x, 0 is y. All right, so moving on. An inverse function switches the values of what and what. You've already written this down maybe. What variables? Jaden.
X and Y.
X and y. Thank you. All you're doing is switching those two because y is equal to x. So in your notes, can you please have something that says, hey, these values of the table go to this one, these values of the table go to this one. They switch, they crisscross here. So up here in the table, just make sure that you have the arrows to let you know that they switched. So here is the big reveal. Are you guys ready? The inverse function of 2 to the power of x, this exponential function that we dealt with last unit, is log base 2 of x. So this y equals, we can now fill that in. This is log base 2 of x. These two functions are inverse, and it's going to be hard for us to wrap our heads around that. 2 to the power of x is the inverse of log base 2 of x. And it still looks like 2 to the power of x. It's just now shifted down by the log function. All right, let's see how the algebra works. So the whole idea today is I'm allowed to switch values of x and y. Graphically, that means flipping over y equals x. In terms of the coordinates in the tables, that means switching x and y. In terms of the algebra, I'm literally going to write, the next step is going to say x is equal to 2 to the power of y. I'm switching the x's and the y's in the algebra too. Let's do it. Let's write it down. This now says x is equal to, give yourself some space, there is some reason that there's space here, 2 to the power of y. I switch it in the algebra. Let me zoom in here so you can see what I'm doing. I switch it. And then I need to somehow solve for y. I need to get y by itself. Yeah, Jade.
I have a question about math, but on
Yes.
this problem.
Okay.
Do you like make these in advance, or do you make them like a week before, or like
I made this one last year.
you just reuse them?
And now I'm going to reuse them once I get... This is a nice lesson, that's why I'm reusing it. Yesterday's, I remade it.
But you make these like a year in advance, or?
I made these last year a day in advance for that class.
Oh, okay.
Normally I make them a day in advance. All right, so in order to get y by itself, I'm trying to isolate y. You've never seen this before. Here is a new algebra trick. And it's a trick that I'm going to be teaching you over and over again. So if you pick it up right now, there's less to learn. In order to get this exponent down into the base, I'm going to take the log of both sides. So I'm going to write log and log. If I take the log of both sides, I will get rid of, well, I will get this power down in front. And specifically, I get to choose, you get to choose, we get to choose whatever base we want. Log base whatever. And the cool thing is, if I do log base 2 down here of 2, these 2's will cancel out. And you already know the reason for this. The reason is it's a what power function. So it's going to be hard for us to wrap our heads around this for now. I'm going to go over this again. But this cancels each other out, and I'm now left with y is equal to log base 2 of x. And I'm going to try to explain that a little bit more thoroughly. But check it out. Let's go ahead and compare that to the table. The table that you just wrote down up here that you can't see off the screen was log base 2 of x. That is literally what it means to do an inverse function. You switch the x's and the y's with the algebra. Ellery.
Why did you just put log base 2 and not like the of when you put it in the equation?
Not the of?
Or like the part in parentheses. Like, because it's normally like the answer is log base 2 of x. So when
Oh,
you
like-
included log, you just said log base 2, but you didn't have the,
Like this?
yeah.
So this is, you can do either form. They're both the same thing. This is a little bit easier to understand, so I could do parentheses around this one as well if you
So
want.
it's like it's of that?
Yes.
Okay.
So this is the part where I'm going to lose roughly 80% of you, but as long as I keep doing things over and over, and you'll eventually see it from a different perspective, that's how you're going to learn. So let me ask you this what power question. Are you guys ready for this? This is going to be hard, but you guys will get this. What power does 2 need to be raised to get to 2 to the power of y?
What?
Why?
I'll ask the question again. Really think about what I'm asking. What power does 2 need to be raised to? So think of the number 2 in your heads. What power goes right here in order to get to the 2 to the y power? Why?
Why?
Oh, okay.
Why?
But why?
What power does 2 need to be raised to get to 2 to the power of y? And the answer is y. Essentially, log base 2 with a base of 2 cancels out, and I'm left with y. I'm starting to get goosebumps because this is really cool. We're connecting like these two really powerful lessons. And you're, yeah. Come on.
Sorry.
It's really cool. Like, it's a what power function. This is stuff that's like way beyond my calculus teacher, and I'm so excited that there's already people in here that are starting to slowly understand why that's working. Question, Jaden.
Is it like that with any, like all of them?
Yeah, so if I, for example, if I wanted to have, if I had like 3 to the power of x, and I'm like, oh, I need to get that x to the bottom. Take the log base 3 of that, and they cancel each other out, and that's all equal to x. That will work 100% of the time, every time, yes.
So I see how 3 and 3 cancel log out?
So log isn't really anything. It's a question.
Okay.
Log is a what power.
So-
This is saying what power does 2 need to be raised to? So it's a function on its own. It's not a number.
Okay, so it's like plus, minus, that sort of.
Yeah, yeah. I guess it's an operation. Yeah, exactly.
Okay.
Yeah, Aurelio.
Oh, no,
Okay, that was a good stretch. Lorraine.
So you always take the opposite, or you always take the base number and then the power of equals y or whatever.
Yeah, these two will always match up in order to get this by itself right here.
Oh, that's really cool.
All right, so let's move down here to the right-hand side. Let's go backwards. We got this. Let's go backwards. So, actually, this is not really going backwards too much, but this is a review from yesterday. If I have logarithmic form, how do I turn it into exponential form? If you don't remember this, flip back to yesterday's notes, 8-1. How do I get log base b of y is equal to x into exponential form? I'm not going to move until at least one person can do this one, because this is exactly from your notes. I see one hand. Let me give more time to look at the notes. At the very end of 8-1, on the very back, the last thing that we covered was the difference between logarithmic and exponential
I
form.
had a different question.
We'll wait until this question is
It's
answered.
about my math binder. I don't know where it's at.
Okay, we'll ask
So
that
if you
later.
see it,
2 people know. There's only 2 people that know how to convert between these forms. Oh, there's a lot more. Yeah, Emily. There it is. B to the power of x is equal to y. Again, that's called logarithmic form and exponential form. Cool, we have that review. All right, so now let's do the problems that will actually prepare you for Khan Academy. I know that it feels like we've spent forever on this lesson, but I think it's been valuable, so hopefully you agree with me. Let's go on to example number 1. I have the graph of y equals 3 to the power of x, which means this is a tripling function. If I plug in 0, I get 1. If I plug in the next value, triple 1, get 3. Triple 3, I get 9. So every 1 that I go to the right, I'm tripling the height. Y equals 3 to the power of x is a tripling function. All right, I need you guys right now to graph the points of log base 3 of x, which seems crazy. You guys are going to graph this function right now on your own. Switch the x and the y values. The x and y value for this one. Label it with me so I can help you. If you already got this, you don't need the scaffold, that's great. This is 0, 1. This point right here is 0, 1. The next point, quiet raised hand. What have we got? This point right here is what? Chewy.
What?
What is this point? Something, something.
It's 3, 1,
Other way around?
1, 3.
1, 3. Perfect. Thank you, Chewy. I'll take your card if you still have it. And finally, this point right here is what, what? Yeah, Caroline. 2, 9. So, what that means for us now, we're going to switch these. So, if I had 0, 1, go to 1, 0. 1, 0, let me do this in a different color, is right here. That is 1, 0. I switched my x and my y coordinate. The next one, switch, 1 and 3, graph it. Switch, 2, 9, graph it. Go ahead and try to connect that with a curvy line, and then you've got your graph. Yeah, Beverly.
Can you go up on the front page? Just the last part, please.
All right. Time to give the answer away to make sure that everyone is following. So I go 3, 1. 3, 1 is right here. I go next to 9, 2, 9, 2. And a good way to check my work is, since I was going right each time by 1, I should be going up each time by 1 and then tripling. I went from 1 to 3 to 9. I'm tripling it. And then go ahead and make a sketch of a line. And there's something that I haven't really stated before that should be stated now, which is this. Come take a look at that original graph. This original graph, over to the far left, it got really, really, really close to the x-axis without ever touching it. It got infinitely close to the x-axis without ever touching it, which means if I were to flip that over the line y equals x, this line right here, if I were to continue it down, it gets really, really, really close to this y-axis without ever crossing over to the left-hand side. which means if I had to draw a parent function, aka the function that you should be remembering for all of these, draw some notes over here to the right-hand side. This is your parent function. A parent function. A parent function is a function that says, hey, all of my offspring from the parent are going to generally follow the same form, which looks like this. Your parent function of a log base b of x will look like this, where it gets really, really, really close to that y-axis, but then comes out through here and goes out like that. So know that it never, ever, ever crosses to the left-hand side. It never goes into quadrants 2 nor quadrant 3. And know that this right-hand side, the top right in quadrant 1, it still technically goes up forever. There's no horizontal tangent. It doesn't get closer and closer to just any specific point. This actually will go to infinity. I can get to 1,000. It'll just take a really long time to get there. There's your parent function. All right, example number 2. We're going to rewrite this in logarithmic form. So, remember, whatever the answer is, I'm going to think of this as my answer, as the power question. So, here's my base. Everyone write this down. This is your base. And I'll zoom in here so we can see from the back. This 9 is your base. This -2 is the power. Can you come up with the what power question? That's essentially what I'm asking. Convert this into logarithmic form. So let me help you out. Log. Log base what of what gives you what? Who can tell me what this bottom number down here should be? Quiet raised hand. Just to answer one question. Yeah, Lorea. 9. Yeah, because log base 9. That's what it literally means to be a base. Base 9. Log base 9 of what? So whenever you're doing what power function, remember that the answer is right here. The answer, I'll write it down, this is a freebie, is right here. This is your answer to the what power question. So can someone complete the next two terms? Log base 9 of what is equal to what? Who's got these two numbers? Remember, the answer goes inside of your parentheses. India.
Is it 1 over 81?
It is 1 over 81. And that's equal to? -2. And think about this in terms of yesterday's context. What power does 9 to be raised to in order to get to 1 over 81? Well, if it's a fraction, it needs to be negative. To get from 9 to 81, I need to square it, so the answer is -2. That makes sense. Yeah, Anna.
So it's the opposite of 9 to the second, 9 squared.
Opposite. Yeah, opposite is the correct use of the word. So opposite means negative, exactly. Yeah, questions before we move on to our final example? Oh wait, I guess this is still part of example 2. Any questions before we move on? All right, so now go and answer the what power question. What power does 1/2 need to be raised to get to 8? Try this one on your own. You're looking at your notes right here. This is the form that I'm trying to make you exchange between this guy and this guy. Exponential form and logarithmic form. Try it right now on this example. I'll leave this up here for your help. I'm trying to get now from here to here. You have it? Oh, okay. All right, quiet raise hand. Who's got this? Yeah, Ellery.
So it's 1/2 to the -3, which can be simplified to 2/3 is equal to 8.
2/3 is equal to 8.
Because like you flip it, because it's negative, so you flip the fraction, right?
So you are correct that you would flip it if I was trying to solve it. I just need to convert it into this form without any simplification.
Okay.
Because you're right, if I flip it and then cube it, then I'll get 8 equals 8. Yeah, that's all you have to write. 1/2 to the -3 is equal to 8. And you should also be comfortable knowing, oh yeah, that is true. If I have a half and take it to a negative power, it flips to 2. And then 2 to the power of 3 is 8. All right, and then finally, the easiest of all of the problems, tables. Again, you're switching your x's and your y's. So I need someone to give me a quiet raised hand. What is the value that should fit right here for 1.5? 1.5 matches up with which one over here, and then switch it. Leo. Say it louder.
30.
Yes, 30. Perfect. Again, that came from over here. It was 30 and 1.5, and then we switched it to become 1.5 and then 30. What about this last box? And we're done with our notes. Beverly. 1.3. Again, because I came over here, 1.3, 20, switch it to 20, 1.3, done. That's the end of the notes, guys.
What do I write for like